to vsdevelopers.io. Today, we'll be looking into inheritance, one of the prominent topics of object-oriented analysis and design. You might have heard the inheritance word in a general regular usage of life. Someone say he has inherited a lot of his parents' property, and someone else has inherited his mentors or a particular person's characteristics or mannerism, right? So when you say that, you don't mean that you own them, right? So they are still themselves, like your parents are, they are by themselves. Your mentor or friends are by themselves. You are influenced by their characteristics. In mentorship or friends cases, when you have influenced, or a particular movie artist, right? So you might be influenced by him, and you might inherit his properties, you might inherit his characteristics, his mannerisms. So it doesn't mean that you have become him, nor he has become you. No, right? So it is only about some of the characteristics, some of the properties of him you have imparted, you have started utilizing them, started benefiting from it. And in case of property, inheriting property from parents, it is the same case. So the property becomes yours, but not your parents become you, or not parents make use of you. No. So the same thing, if you apply the general formula, general understanding of inheritance into object orientation, it becomes a lot easier to understand. So there are multiple ways, as we have seen in the example, like you inherit property from your family, or you inherit a particular characteristic from your favorite movie artist. So there are different ways of inheriting, and there are multiple ways of inheriting, right? So let us relate this general life example with C++ object orientation. So it would be easy to understand it that way. So let us look into it. Now, how do you define inheritance in C++ way? Here is the definition that you go. Inheritance is a mechanism of reusing and extending existing classes without modifying them. Again, a feature that enables a class to acquire properties and characteristics of another class. Right? So what are we doing in family property inheritance? You are utilizing them, isn't it? So there is understand that that's an existing class, and you are a new class. When you inherit, you started using the characteristics, you started using the behaviors and properties, assets of the existing class. Where are you using it? Who is using it? The new class, that is you. So you are a derived class. Now coming to the terminology, you are a derived class, and this derived class started utilizing the properties, the characteristics, the behaviors of the existing base class. So that is called base class. Well, so base and derived class is the standard terminology in C++ object-oriented design. If it's a family property, you have legal document, right? So there is a method. And if it is a characteristic of your favorite actor, then there is a method how you have inherited that particular characteristics. Likewise, now you have a syntax, right? There is a certain way how you inherit. So if you take a look at a typical way of designing a class, right? So you have class A, right? And this class A has certain private members, and then you have public members, right, with the keyword public access specifier, and you close this class and your abstract data type is ready here. Assume this is the parent, that is the base class, and now you have class B, which is you inheriting property or the characteristics from A. You want to inherit it, that is, you want to make use of the characteristics or properties of class A. How do you do it? Right? The syntax is, so when you are inheriting, you put a colon beside the new class, and then mention the access specifier, that is, you want to derive it privately or publicly. We will talk more about it. And then you give the class name from which you are going to inherit. Well, so this is the new syntax that is being introduced here, which was not seen before in C++. Now what can you do inside this class B? You can access all the members and member functions in public here. right? So if you have a fun A, right, in this class A, now you are entitled to call this fun A from class B without explicit mentioning of it, because you are entitled now. You are entitled to use class A because you have inherited them. Well, so that is the basic syntax of how you declare it. Now let us look an example with the code how you actually write program and access the members. Look at this class. So this is meant to be a base class for our demonstration. Now class base has int I, a private member, and public has the constructor which initializes the I to 0, and then there is a set function which sets the value, and a read to return, and then permute multiplies it by 47 and returns the value. Well, so this is a base class, easily understandable. Now let's go to derived class. So what do we have in derived class? So we have class derived. As we discussed, the syntax is public base. Now this derived class has its own variable called I, which is different from your base class I. Well, now public, it has its own constructor derived which initializes this I to 0. And now if you see, there is a method int change. This is derived class member function, and you are assigning I to the value of permute. Where is this permute coming from? Does this derived class has a method called permute? No, it doesn't have. So this is all the definition of derived class. So you are intuitively using the members of base class. So you are using as if it is yours, right? So permute, and then you returning the value, and this set is different from what the base class set is. But now what are we doing here? So this class sets the value to I, which is local, and then you are calling base class set, because you have to differentiate between this set and the base class set. Therefore you use the scope resolution operator and your class name, right? So you have II. So with this, what happens? You are setting the value to, you are calling the function of base class, right? So this is your derived class. This is how you will make use of permute function, set function of base class. But it doesn't have read, if you see, right? Now let's go and use how it can be used in the application. Now we are, for demonstration purposes, we are printing the sizes of the objects. So if you see the first one, we are printing the size of base. What is the size of a base class? And then second, we are printing the size of y. All right. So then I have declared an object called D of derived class. So then I am calling d.change, then d.read. Did I define or did I declare the read method inside this class? No. See, but I am directly calling the read because I am an inherited class. I am a base child class, child class, or I am a derived class. I am entitled to use the characteristics of base class. So therefore d.read, and then I am calling d.permute, and then d.set. All right. So then we can see printing what happens. Now if you just check this value, if you run and see, you will get the sizes. Now in order to see how the inheritance, that is how you are making use of your existing classes, this is a good demonstration. We will run it and see. Let us look at the application, how it's being used. I have updated the code for the better demonstration. So what I'm printing first is size of the base, right, and then the size of the derived. So with which you will understand how the derived class size increases, because in other words you are deriving the property of the base class. So it should be the derived class size plus the base class size together. And now you have an object derived D. So d.change, right? So d.change should essentially call this member function, and what it is supposed to do, right? So it says I is equal to permute. Permute, as you have seen, which is coming from the base class. So what is there here in the base class? So I, this I belongs to, see, as the IntelliSense shows, it's a base class I, right? So when you declare the object of derived class, at that time, because you have inherited it, your base class constructor also gets called. Remember that. So first base class constructor gets called, and then derived class constructor gets called. So as soon as you have declared this derived D, behind the screens, the constructors, sequence of constructors gets called. Now go back to your constructor base class I is initialized to 0. So here when you multiply, this is operating on this local I. So 0 into 47, 0. So what is returned is 0. Now you come back here. So what is the value if you print d dot change, and coming here, so the permute is returned 0. So this I, which is derived I, you see the IntelliSense, right? It's a derived I. So the value at derived I is 0, and you are returning this I, which is 0. So here when you print d dot read after d dot change, you should be getting 0. So this is to demonstrate how the member variables and member variables between base class and derived class play. Next, you are calling d dot permute, right? So when you say d dot permute, what is supposed to happen? So it comes, and there is no class here, so you can directly call base class. So you go to derived class and then say return I is equal to I into 47. Again the same thing, there is no change to the I value, so it returns 0, right? Just to demonstrate that. Now d dot set of 12. So d dot set, that is you are calling this set, and which is taking 12 as an input. Now you are assigning 12 to this I. This I is local I, right? And then you are setting also the base class. So this goes and sets here, set. So now the base class I is also set to 12. Well, so base class I is set to 12 and derived class I is set to 12. Now if you print here d dot read, what is supposed to come? So it goes to the read method and returns I, which is base class I, right? So which gives you 12. Well, now I'm calling d dot change. This time when I call d dot change, it comes here, it goes to permute, right? So permute I into 47, so which is 12 into 47, and returns that value of I. So when I print d dot read, it is supposed to print 12.47, right? So let us quickly run it and see. Alright, so the first size of base class is 4, size of derived is 8, as we discussed, is the double. And now d dot read after d dot change is 0 because the base class I is 0, and d dot read after d dot set is 12 because we have assigned the value here, right? And then you printed it, so which prints you 12. Now with this your base class value is also 12, and with this your derived class I is also 12. Right? And then what you are doing is d dot read, which goes to which prints this d dot change, actually goes to permute and multiplies and then prints, which is 564. Well, so this is how your inheritance of base and derived classes come into the picture. So it might seem complex, but try to understand. It's a base class property you are inheriting, and then into derived class. And when you get into derived class, right, you can make use of all the properties of the base class. That's an unfair advantage you get with inheritance, where you can use the code very, very well. So you don't need to rewrite functions that are already there. So for example, you take a library that you have bought from a third party. What can you do? So you can inherit from them and then directly start consuming them. What is the other way is object composition. So you can directly declare the object of that class and start using it. So that's another way. And this has more wider usage because of its reusability, because of its simple, easier binding that happens. Well, so as we go forward, we will look more varieties of variety ways of implementing and using the inheritance. Your base class, right? And so a class, as you know, is represented with a UML diagram in this way. And then, so this is your base class. And now when you have your base class, right, and you have a derived class. So for easier understanding, I am simply using it this way. So you have derived, right? You have inherited this. So if you say this class derived is of type base, right? So that derived can make use of all the base classes. Now if you have in the same fashion, so assume this is a class, one base class, and who stops, right? So some other developer can also inherit from it, isn't it? So, or you can have two classes from which you want to derive from this base class. And So you have a base class and you have a derived class, and you not only derived from B base class, but also you have derived from another base class called A, right? So this is another way of inheriting. So this is your simple inheritance, right? So this is your simple inheritance. Either your class, essentially your D1, let's say your D2, D1 inherited from one single base class is your simple inheritance. And here if you see, your derived class has inherited from two base classes, right? So this is, as you can understand, it is multiple inheritance. And what stops someone else deriving, right? So your D1, it is possible, right? So your E1, a new class, someone wants to make use of your class, so they inherit from your D1. So this is, as you see, multiple inheritance, that is, sorry, multi-level inheritance. So you are extending the inheritance multi-levels. So therefore this is multi-level inheritance. And any of this combination, if you mix, that becomes your hybrid inheritance. So say here multiple inheritance is into D, and you have another class E, right? So what you are doing is you are inheriting in a hybrid fashion, right? So these are the various types for your knowledge. You can when you are asked in an interview, you can answer it. Okay, simple inheritance is directly deriving from one single class, and then multiple inheritance is deriving it from two or more classes, and multi-level is extending the inheritance to one level down or more, right? So that is multi-level. And then hybrid is mix and match of simple, multiple and multi-level, any fashion. So this is for the knowledge sake. In real time, when you are developing the application, you will make a judgment whether using of simple inheritance is good enough, which is a good practice to not to create too many confusions and debugging challenges. So multiple, if you can't avoid, you need the benefits or properties and characteristics of both the classes, yes, go ahead and do multiple inheritance. Multi-level is typically to be avoided because there are, now you have seen in the example, right? So you have the base class I and derived class I. You see how it's being played if you call set. So though you don't have an object of base class in the example that we have seen, what you have is only the derived class object. With the derived class object, how you are able to make call to base class constructor, how you are able to make calls of base class member functions that change the data, right? So you should be cautious and careful when you are using multi-level inheritance, and so is the case with hybrid. So you are the best person to make a judgment whether to go for single, multiple, multi-level or hybrid. Well, so with that, we'll wind up the introduction of inheritance, and we will see more and more use cases and interview questions in upcoming videos. So until then, do subscribe to vsdevelopers.io, leave your comments and leave your feedback on how you would like to understand the concept. If you have any open questions that I can create another video and make you understand. Thank you for watching.